Hi, welcome back, Math Gurus. Today's video, we're going to focus on solving one-step equations using algebra tiles. It comes directly from TEK 6.1a. All right, so let's go ahead and get started. And so in elementary, you were given questions that were phrased in the aspect of find the missing number. And so it may have looked something like this: 5 plus blank equals 17. And so that blank was your missing number. And so one of two things happened. You knew that 5 plus 12 was 17, and so their missing number was 12. Or if you didn't know, you knew to just subtract 5 from 17. And you still got 12, so that was your missing number. So let's bring it up to 6th grade math, and it would just be phrased as 5 plus x is equal to 17. And the question would be phrased, solve for x. X is your variable, and it's a letter that represents an unknown value. We typically use, and when I say we, I mean teachers, we use x the most, and then y and z. You can use any letters of the alphabet, any 26, but those tend to be the most popular. All right, so if you look on the left side, those are algebra tiles. So when I say we're going to model using algebra tiles, that's what we're doing. The green rectangle is a positive x. So you just put positive x just like that. The opposite of a positive is negative. So the red rectangle would be a negative x. Those small squares, those are just like the counter chips. One side is positive and one side is negative. And so the yellow is still positive and then the red is negative. The right side is strategically for algebra class, so you won't need that in a junior high math class, but I wanted to show it to you anyways. The red is negative x squared. Red will always be negative, and then the blue would be positive x squared. Now, we'll use equation maths to solve along with the tiles to solve for our unknown because we want to get one positive x all by itself. Okay, so in this case, it's 4x equals 12. So 4 is your coefficient. No one ever asks you that. I think if you're in my class, I use vocabulary cards. I start introducing it at entrance tickets, and that's one that stumps everybody. X is your variable. Okay, and then 12 is your constant. Okay, and constant means just a number that stands alone. Now, this is like a balance scale, so the left side is equal to the right side. And if you want to keep it balanced, whatever you do to one side, you do to the other. So 4x is on the left and 12 is on the right. Now, what I'm going to do is I'm going to draw 4 positive x. How do I know it's positive? Because there's not a negative sign in front of the 4 or a negative, or a subtracting operator, sorry. Okay, so for 4 positive x, and I'm laying them down like this on purpose. It'll make sense in a second. I'm not going to color it in because it just takes too much time, and I try to keep my videos short and sweet best as possible. There's 4x, and I have to share those 12 units amongst those x's because, like I said, I want to know what one positive x is. I'm going to go as fast as I can. 1. And so it's like you get 1, you get 1, you get 1, meaning when I say you, I'm talking about x. Sure, that's not grammatically correct. So keep going. So I'm just going to share these 12 positive units. Okay, now each x has 3. So what that tells me is that x is equal to 3. Now you can always go back, plug in your solution. So the original equation was 4x equals 12. We'll plug in a 3. We're going to use parentheses. That does mean multiply. 4 times 3 is 12. So yes, the left equals the right. This actually will work for every equation that you are ever exposed to on solving equations. So you shouldn't get any of them wrong. All right, let's do another problem. So this one is x plus 2 is equal to negative 10. So x is still positive, so I'm going to use the green tile. I need 2 positive units on the left side. Now on the right side, it's negative 10. So I'm not going to use the yellow. I'm going to use the red. So I need 10 of those. Now, I want to get rid of the positive, and the way I get rid of or I undo anything, I'm using the inverse operation. On the last example, I'm not sure if I said that, but we actually divided. I didn't want to say we were dividing. I wanted to show you that we were dividing. If I want to get rid of 2 positives, well, the opposite would be 2 negatives. So I'm going to add 2 negatives on the left side. And remember, if I'm keeping it balanced, whatever I do to one side, I have to do to the other. So I'm going to add 2 negatives on the right. Now, 0 pairs, refresh your memory, they are opposites and they cancel each other out. So there's 1 0 pair, there's 2 0 pairs. Now I'm left with 1 positive x, and then you look on the right and there's just 12 negatives. There aren't any 0 pairs on the right side. We're not worried about that. Now the solution is x equals negative 12. If we did it correctly, we should be able to plug this back in, negative 12, substitute the negative 12 for the variable, plus 2 equals negative 10. If it's right, the left equals the right. Well, negative 12 plus 2, if you're looking at it as a number line, you go down 12, you come back up 2, you ended up at negative 10. So yes, it is correct. The left equals the right, and x does equal negative negative 12. Thanks for watching. I hope it helped.